I think we're in business. Well, good afternoon, good morning to everybody. Please let Erin know if I'm too loud or too soft in my volume. But this is the last of our Monday morning, Monday afternoon chats. So I appreciate you joining me on this day. Hope you're having a good day. I hear some people are in Washington. And it's springtime here in Boston. We had temperatures close to 60 today. Um, I hear we might get rain or snow in the next day or so, but it's still far from cold. So hope you're having a good day. And what I'd like to do today is finish talking about using SAS to analyze that Ohana data, say a few words about sample size calculations, so someone had a question about that, and answer any questions if we have time. I'm going to be trying to switch back and forth from different software. So what I'm going to try to do is switch over to the wife's laptop screen. So it's a little bit novel to me also. Some of her keys are in different places than my keys. So let's see what happens if I stop sharing and go to my computer screen. Go to share. Pull up some PowerPoint slides first. Let's see, I'll close that, I'll open this, and let's see what happens in a second. Okay, so let me do a check. Erin, if you're with me, just turn your mic on and let me know if you're seeing the PowerPoint
it's not coming up on our side. It was up before, but it disappeared. Okay, now it's back up. We can see that.
What are you seeing right now?
What are you
seeing your
seeing
desktop.
right now?
You see the slides?
You see the slides?
Not yet. I'm seeing your back your
my desktop, but you see it? Not yet. I will wait a second.
Okay.
Okay, well, let's see. Let me know if I say something that doesn't match what you're seeing then. Okay, so let's first finish talking about the analysis of that hypothetical data set I gave you. If you remember, the data set's looking at a series of patients, a series of subjects, participants in a study, some of which were given a lifestyle intervention, some which were not. The main outcome of interest is mortality, death versus non-death. And we wanted to know whether the lifestyle intervention had any effect, hopefully a beneficial effect for decreasing mortality. And where we left off last week, and this will turn to SAS in a few minutes, was beginning to fit models, looking at the relationship between the main intervention variable, the Ohana variable, the lifestyle intervention variable, and the outcome death. But let's just talk a few slides first about the main problem with data like this. The data I gave you was a non-randomized study in the sense that individuals were not randomized to receive an intervention or not to receive an intervention, but communities were. One community received the intervention, another community did not. And since the outcome is the mortality status of the individuals living in that community, you're concerned that the subjects who received the intervention might be different from the subjects who didn't receive the intervention. What you're concerned about is the potential for confounding. The challenge is to identify the potential confounders and to adequately control for those potential confounders. So the first thing you should be thinking about when you design a study like this is what are the other factors that might cause one group of people to have higher mortality rates than another? What are the other factors that we could collect on these individuals so we could adjust for these factors that might influence a person's chances of dying? So initially what we do in these studies is we try to imagine the other potential risk factors for causing the main outcome, death. And then we want to examine whether these factors are balanced in the two groups we're comparing. So when we look at confounders, look at the potential confounders, it's usually a mixture of prior knowledge to figure what other people have identified as risk factors for increasing a person's chance of dying, and also partly empirical, partly looking in the data set to see if those risk factors are balanced in the two groups we're comparing. So in terms of the first step, the prior knowledge, we might, in our mind, start drawing a diagram, a causal diagram. And I've just advanced the slide. Hopefully you'll see this new slide in a second. If you don't see the second slide in a second, Aaron, just come on and tell me. But this is a causal diagram in an epidemiologist's mind. What the epidemiologist wants to know is whether the intervention of interest, the HANA intervention, might increase the chances of dying or decrease the chances of dying. So they're interested in the existence of this top dotted line. They want to know whether there's a causal link between receiving the intervention and decreasing your risk of dying. But the problem is that we know that there are many reasons that people might be at higher risk or lower risk of dying. For example, we know that older people die at a higher rate than younger people. We know that men have a higher risk of dying than women. We know that people with very high blood pressures or people with very low blood pressures have higher risks of dying. High cholesterol is a risk factor, a high risk category for dying. Diabetes increases your risk. Maybe marital status has some influence on your risk. It's been shown in some studies that married people might survive longer than single people. If you have had previous heart disease or a previous stroke, previous cardiovascular disease, you might be at higher risk of dying. And a factor that the people in Marjorie's group have been looking at is whether body mass index might be increase a person's risk of dying. So what we have in our mind is and when we think of this causal diagram, are these other factors, age, sex, blood pressure, cholesterol, etc., that have two properties. Based on prior knowledge, they might be risk factors for dying. So in other words, we postulate there's this arrow that's connecting each of these potential risk factors to the outcome mortality. And what we're also concerned about is whether there might be another arrow connecting these factors to the intervention. We might be concerned about whether the people who receive the intervention might be younger than the people who didn't receive the intervention, or they might be a higher percentage of men, or a higher distribution of blood pressures, cholesterols, or what have you. So if there is such a link, let's see, Aaron, my phone is ringing. Is you by any chance?
Hi, friend, that's not me.
Okay. I'll let it ring then, because I'm sure it's someone trying to sell me something. Okay, thank you. So what we're concerned about are the existence of this alternative pathway that we discussed a few weeks ago. In other words, that might be another way for which the people who receive the intervention might have higher risk or lower risk of dying. If the people who receive the intervention are younger, or if they are mostly women with lower blood pressures and normal cholesterol levels and no diabetes, and they're married and have no history of cardiovascular disease and normal body mass index category, then compared to the people who didn't receive the intervention, that might be the reason why the intervention group has different outcomes. So what we would be looking at in our data set, and this is what we did 2 weeks ago, we would build a table 1 to look at the age, sex, blood pressure distribution in the intervention group compared to the people in the non-intervention group. And that might give us an idea of whether these potential risk factors are likely to be confounders in our data set. So typically that is what we do. And this gives us a sense for whether we have a potential for confounding. Because if we see that the two groups we're comparing have different age or distributions or sex distributions, then we have the concern that those different distributions of known risk factors for mortality might be the reason we see a different mortality experience in the intervention group than the non-intervention group. Now, I said in this slide that this gives us a partial sense of confounding. Partial in the sense that it's telling us, crudely speaking, whether the age distribution is the same or different in the intervention group and the non-intervention group. But in our model, once we start controlling for another risk factor, say we decided we're going to control for body mass index as a potential confounder, then what we really want to know is whether the age distribution for the intervention group is different from the non-intervention group within categories or within levels of body mass index. We want to know whether controlling for